Welcome to Spaceverse, your portal to cosmic adventures. Did Albert Einstein foresee something incredible? Was he right when he predicted that we'd never be able to see the edge of the universe? Well, the James Webb Space Telescope might just have found evidence that could confirm his prediction. Recently, Webb observed what appears to be a void in the extremely early universe. But what are we actually seeing here? Is this truly a void, or could it be something even more profound, the very beginning of the universe itself? Over a century ago, Einstein's theories reshaped our understanding of the cosmos. And now, scientists might have stumbled upon a strange and shocking fact, a mysterious void at the dawn of time that could validate one of Einstein's remarkable predictions. Imagine this. 100 years ago, astronomers were just beginning to explore beyond the Milky Way. At first, all they saw were hazy nebulae, but as their technology improved, they realized these nebulae were actually entire galaxies. First, the small and large Magellanic Clouds came into view, followed by the stunning Andromeda Galaxy. And soon, scientists were astonished to discover just how many galaxies are out there, an overwhelming number that reshaped our understanding of the universe. Now, with the Webb Telescope's cutting-edge technology, we're once again on the brink of a major discovery. Could this void be the key to unlocking the secrets of the universe's origins? And if so, was Einstein right all along? Stay tuned as we continue to explore these mind-blowing discoveries. Don't forget to like, subscribe, and hit the bell icon to keep up with the latest in space exploration and the mysteries of the cosmos. The discovery of distant galaxies moving away from us by Edwin Hubble led to the revolutionary idea of an expanding universe. Shortly afterward, Belgian physicist Georges Lemaître proposed the Big Bang theory. These significant developments occurred shortly after Albert Einstein introduced his theories of relativity. Many theoretical predictions made by researchers in the 1910s and 20s were later confirmed by these discoveries. Despite fundamentally accepting the Big Bang theory, Einstein remained uncertain throughout his life about whether the universe truly had a beginning and an end. However, he was unwavering in his belief that even if the universe did have a beginning and an end, we would never be able to see them, no matter how advanced our telescopes became. But how did Einstein arrive at this seemingly outlandish idea? And what connection does it have to the mysterious void recently discovered by the James Webb Telescope? Albert Einstein's alarming prediction. Einstein was undoubtedly one of the most influential physicists of the 20th century, and many of his predictions continue to be foundational in modern science. One of his most profound insights was the prediction that we could never directly observe the absolute beginning of the universe. Einstein provided two compelling reasons for this. Firstly, according to the Big Bang theory and related theories, there was no light for hundreds of thousands of years immediately following the Big Bang. This period is now known as the Dark Ages. Without light, how could telescopes possibly observe that moment or event? While there are intriguing modern answers to this question, such as the use of radio telescopes, which hear rather than see, it remains unlikely that the Big Bang was accompanied by any sound. In fact, scientists believe the Big Bang was a completely silent event. The space in which a sound could have occurred didn't even exist at the time of the Big Bang. Space itself came into existence as a result of the Big Bang. Radio telescopes detect waves far beyond the audible sound spectrum, and space, being a near-perfect vacuum, hardly conducts sound. Only a few types of waves penetrate the interstellar medium, and with modern technology, these can be converted into sound. However, this means we wouldn't really be able to hear the presumably silent beginning of the universe. We first discovered cosmic background radiation in the 1960s and have since mapped it extensively. This radiation is believed to be a remnant of the Big Bang, and much of the evidence supporting the Big Bang theory comes from it. However, the microwave background has never led us directly to the Big Bang, so it appears we still have no way of detecting or proving the absolute beginning of the universe. Einstein also believed, for another reason, that we could never see all the way to the beginning or edge of the universe. He thought that as the universe expands and extends, the beginning would move further away from us, effectively pushing it out of our range of vision. Additionally, Einstein sometimes believed in the curvature of space, suggesting that the starting point could be hidden behind a kind of horizon, forever obscuring our view. Consider that Einstein had these ideas when the best telescopes could only produce blurry images of neighboring galaxies. Today, we know of the existence of millions of galaxies in an ever-expanding universe. One might think that this would make it difficult to see far, but that's not the case. Despite the richness of our cosmos, the vast spaces between galaxies and galaxy clusters allow us to see 13.6 billion years into the past with our current telescopes, very close to the Big Bang. With the James Webb Space Telescope, we're getting incredibly close. But interestingly, the Webb Telescope isn't showing us the Big Bang as scientists envisioned it 100 years ago. Instead, it has discovered a strange void. You might have heard that the James Webb Space Telescope has discovered an astonishing number of very old galaxies, which has even led some to question the Big Bang theory. However, did you also know that the jwst has uncovered a peculiar void that might support Albert Einstein's prediction about the impossibility of observing the absolute beginning of the universe? These absolute voids are enigmatic regions of space that are so empty they actually challenge the theory of relativity. How could such voids validate Einstein's ideas about the unobservable nature of the universe's beginning? Initially, the emptiness was thought to signify the Dark Ages, a period shortly after the Big Bang when there were few stars or galaxies. This finding seemed to confirm the existence of this epoch. But then came a surprising revelation. The darkness was actually an extremely distant void. We are aware of other, more recent voids that present their own mysteries. Yet, in the context of the very early universe, these voids are even more puzzling. They contradict the concept of the universe's homogeneity, which is fundamental to the Big Bang theory and the idea of cosmic expansion. These voids are too vast and anomalous, challenging some of the core principles of our cosmological understanding. A void itself doesn't directly confirm Albert Einstein's prediction. However, the James Webb Space Telescope seems to align with Einstein's views in another way. The telescope has yet to uncover any evidence of a beginning or early stage of the universe. The images of what are thought to be extremely early parts of the universe reveal structures and galaxies that don't appear significantly different from those we observe in the closer universe. This raises the intriguing question, could a void have been the origin of the universe? We cannot entirely rule this out, as we still don't fully understand what voids are. It's also true that we don't have a complete picture of how the universe began. Voids are thought to be empty, but we can't be sure of that. It's possible they contain forms of matter we haven't yet discovered. Consider the idea of dark galaxies. Voids are sometimes viewed as potential parallel worlds, and some scientists speculate that they might be remnants of cosmic collisions in a multiverse. More speculative theories suggest that aliens might darken galaxies within a void to harvest energy. These mysterious voids push the boundaries of scientific understanding and inspire a range of extraordinary theories. The possibility that our universe was created within a large void, while speculative, is reinforced by the fact that we cannot prove otherwise. This leaves us with the fundamental question of how matter itself was created. What exactly are singularities? We've discussed the concept of the nothingness from which the universe is thought to have emerged. If this was the absolute starting point, how could we ever observe it? After all, it was nothing and therefore indetectable to us. A singularity is a point where all forces are so condensed that our measurements of values and sizes break down, or where everything that exists is concentrated into a single point. This point represented a fluctuation of possibilities in a state of complete equilibrium. An unknown event is believed to have disturbed this equilibrium, leading to the onset of creation. From this infinitesimal point, everything we know and observe today came into existence. This means that the information for you, me, all life on Earth, every star, and every exoplanet was once contained within this minuscule dot of nothing. The question of how such a tiny dot of nothing could contain everything is one of science's greatest mysteries, and it's currently uncertain whether we will ever resolve this puzzle. We also encounter these enigmatic singularities at another location in the universe, the centers of black holes. Black holes are thought to be remnants of stars that have exploded, and they are found at the centers of nearly every known galaxy. No one has ever observed the center of a black hole, and as we've discussed, we have very limited means of observing the absolute starting point of the universe if it even existed. Everything is based on calculations that seemed accurate until the James Webb Space Telescope discovered data that deviated from our theories. The Webb Telescope suggests that the universe might be much older than previously assumed, or that its nature differs significantly from our predictions. Black holes are among the most profound enigmas in cosmology. They are vast and immensely massive, with forces within them likely reaching infinity, making it impossible to explore these infinite points, which are linked to singularities using traditional methods. The current focus is on new supercomputers, which, with their advanced capabilities, are expected to unlock the universe's secrets and reveal its underlying connections. To achieve this, scientists are utilizing quantum intelligence, thought to be the universal information repositories of the observable universe. At the same time, other chip technologies are harnessing the storage potential of water to achieve remarkable computing power. And that's it. Thanks for joining us on Spaceverse. Today, we delved into the mysteries of black holes, singularities, and the latest discoveries from the James Webb Space Telescope. From the enigma of cosmic voids to the cutting-edge technology aiming to decode the universe's secrets, it's clear that our journey through space and time is far from over. Don't forget to subscribe for more deep dives into the cosmos and updates on the latest space exploration news. Until next time, keep looking up.